This is the LED driver. This wire and this wire are live and neutral in for 240 volts here in the UK, and this wire and this wire are plus and minus out for one strip of LEDs, and here would be plus and minus out for the other strip of LEDs, but I've unsoldered those two wires, and obviously I need to unsolder these two next. Now I have been testing this capacitor, this capacitor, this capacitor, and the ones I've tested so far have all tested fine, and I had some problems trying to test this and this. These turn out to be inductors, and I've tested these and they seem to be absolutely fine. So what I've got is one of these boards stripped down, so you can see that's the same board, but capacitor, 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 big capacitor, big capacitor, inductor, inductor. So I've just taken those components off while I've been testing, and it's easier now to look at what's on the other side. I've tested this bridge rectifier, that's absolutely fine, and I've gone round and tested as many of these other small components as I possibly can, and they're nearly all resistors. There's only two capacitors that I can't really test without removing, but they all test fine. So what I'm left with is that chip there and that chip there. I'm just going to test a few resistors just to show you that they all seem to be okay. These are very low ones here. You can see they're coming out as about 1.7, but I suspect these leads are probably nearly that. 0.9 on the leads, so they're low anyway. So those two, and then this is the other side. 1.7, 1.8, 1.7, 1.8, and then a lot of these others are quite high value. So if I go to, let's say, that one and that one, give or take a little bit, 200, cross onto that one, more or less 200. If I go here to here, almost 300, here to here, almost 300, and then those two are mirrored over here, 300, 300, and I think that just leaves us with that one, oops, just coming out at about 10, and then that'll be the opposite one on the other side, 10. So they all test absolutely fine. Diode here and here, put it on diode check, nothing, about 600, swap them around, that one should now read nothing, which it does, and this one should now read about 600, which it does. So the diodes are fine, all the resistors are fine. Got two capacitors, there's one there and one there. I get no reading across that, so they're at least not shorted, and I get no reading across that one. Now that's a board which hasn't got anything on the back. I've already taken the components off the back, but I've done the same check on this board. Everything tests okay. Right, it's not easy to see, but that's one leg on the chip, and then there are two legs there that don't appear to be connected, and then there's another leg there. So that's four legs this side, but that one there and that one there appear to be connected. There's the dot on the chip, which I think is next to ground, and then on this side we've got 1, 2, 3, 4 legs, and I'm not 100% sure, but they look like all four of those are connected. I think this is the chip. It's a BP9833A, and I think the dot that we were seeing on the chip is here next to the ground pin. I'm not 100% sure, but I think it is. So then we've got pins, and I don't understand the numbering on the pins because it says 1324, which strikes me as a bit odd. I would have thought that was 1, 2, 3, 4, 5, 6, 7, 8. So I'm wondering if they've misprinted this, and that should be 1, 2, 3, 4, 5, 6, 7, 8. But obviously I don't know for sure. You can get an idea of what's connected to what because this is the suggested typical application. Here's the incoming bridge rectifier, which on here is this. So if I turn this round, that's that there. And then this would be the big capacitor, which is that one. And then I'm assuming that this here is the inductor, so that would be one of these. And then we've probably got another capacitor here, which is probably the equivalent of that one. And then here is where our two outputs would go, or here, so that would be our plus and our minus outputs, and that would then go here to our string of LEDs. So it looks like most of the things that we could expect to see on here and on here are here. And if you look, this is in effect 2. What we've got is live and neutral coming in, being rectified, putting into this big smoothing capacitor, and then it splits into 2 halves. So this is one half of the circuit, so that's one LED driver, and this is the other half, that's the second LED driver. And so this one runs one strip of LEDs, and this one runs the second strip of LEDs. Now the reason I'm interested in looking at this is the only replacements I can find do not do this. They just have one of those and one of these. And what they do is they go plus into one strip, back, and then across to the second strip, through that strip, back, and then back into minus. So they only have this. They do not have 2 of them. That's all right, but this design is quite handy because if something goes wrong with this strip of LEDs, this strip stays lit. With the new design, which uses only one of these, the power goes through both strips. So if one strip fails, the whole thing goes out. So you don't get a clue of what the problem might be until you can actually test it. But coming back to the actual chip, there's our chip, and there's our chip there. If it's very difficult to make out, but I think that's a dot there. And the problem with that is that I cannot seem to turn it around and get... I thought the dot for the ground would be there, but on this it would be over here, so it would be in a different place. So I haven't quite worked out how this goes, and I particularly haven't worked out quite how it goes because of the way it wires up, but I'm going to try to work it out. I've got 1, 2, 3, 4 connections there, which could be 1, 2, 3, 4, and then on this side I've got 1 and 1, and these 2 not being used, and on this side I've got drain, drain, CS, CS. So you could, if you look, they're connected together, and that one is connected to that one. So you could easily say, I don't use those 2, and just use 8 and 5. So I think that's probably the way round it is. In which case, that little dot is obviously not a opposite ground, it's here, next to VCC. So I think that must be the way round that this sits. Now what I want to know is what should this be doing, because it seems to me that one of these sides of the driver is working and this side isn't working. Oh, and by the way, that diode there would appear to be this diode here, and it tests okay in all of them. So, and then of course I think there is a capacitor there with a resistor there, and my best guess is that that capacitor is this one here, which on this chip is this one here. So I think that's what those are. And then of course we've got quite a lot of resistors. This looks very similar to that circuit. So I'm wondering if what caused this to fail, and I've got 3 of them that have failed, is one of these chips has packed up. So that's what I need to find out. Is the fault one of those chips? Because so far I can't find a fault on any other component. Right, hopefully you can see what I've got here is I've got power coming in here, so that's live and neutral there. No earth, because it doesn't have an earth. This side I've got connected plus and minus to this meter here, and this side I've got connected plus and minus to this meter over here. There's no load, so the voltage will rise way up because there's nothing to clamp the voltage down. So you'll see that for yourself. Right, I'll switch it on. Now you can see this one is reading 330 volts, which is about what you would get coming in off of that main capacitor, so that just seems to have gone all the way through, and that will probably clamp down to about 80 volts once it's got the strip on it for the LED strip. But this one is reading nothing. So the output to these two here is nothing. And as I say, so far on all of the ones I've tested, well especially this one that I stripped right down, everything has tested out okay. So I can't find anything wrong. So the only thing I can think of is the problem is the chip. But at least we now know on this particular board, that one there, where I've trimmed it short, is the problem side. Right, power's on, so we've got to be very careful, and it turns out that the picture that I took off the internet is complete nonsense. I'm pretty sure this pin up here is ground, and this pin here should be the input to the chip, and give or take a little bit, it's 12 volts. And then the output from the chip, which is the drain, I think is there. And you've got 2 pins, and they're about 30 volts. So we've got about 30 volts. That's the side that's working. If we go to ground on this side, and then power supply, about 11 volts, so about 12 volts. And if we go over here to the output, look what we've got. 278 volts, and the pin next to it, which is not connected, but again the same voltage. So this chip is putting out a monstrous voltage in comparison to that one, and this side is working. So I think this chip has failed. I'm going to try to add some low melt solder to the chip with the soldering iron. I'm not sure the soldering iron is the best for doing this, but still we will try. And that's that side, and then we've only got that pin there on this side and that pin there. Right, so that's a little bit of solder added, and I don't know what chance we've got of getting hold of this with the tweezers. Slim, I suspect, unless I can just pick up an edge perhaps. You would think that that would be loose enough to lift up a fraction, but no, doesn't want to know. No, it just doesn't want to know, does it? Look at that. I don't want to leave her too hard because I don't want to damage the track. No, it doesn't want to touch it. I should think that must be unsoldered by now. And why is that not lifting up at all? Come on, why are you not lifting up? Oh, starting to lift, starting to lift. That's it, off. With a bit of luck. Let's hope we didn't do any damage. I'll give those a better clean in a minute, but that's that one there, that's that one there, so they seem okay. You can probably see this better than I can. I can't actually see from the angle I'm looking at what's happening here, so I'm just guessing that I am in some way cleaning these pads up. You could well be screaming at the thing saying no, you're shorting the pads out, but I just can't see. I'll find out when I watch the footage back. Right, just to show you what I mean of this clamping down effect, I've put those two wires onto the LED strip. You can only see the first little bit of it because it's 4 foot long, but it's there. I'll turn it on, there you go. So that side is working, so this side here, this is all working, but this side over here doesn't work. Now if we carefully try and test whatever voltage we've got on here, you can see we've got 77.4. It's somewhere around about 75-80 volts. That's the sort of thing you expect to get on these LED strips. Looks like two of the LEDs have just packed up. But if I go on to this other side over here, you can see basically we've got nothing. I have just taken these off of this circuit board, which is the one that I took apart. And if you try to test resistance from pins to pin, or if you try to test as if there was diodes from pin to pin, both of these test pretty much the same. Now how that's possible I don't know, because presumably one of these is faulty. Because there's the faulty one that we took off of this board, and these are the two that I've taken off of this board, and obviously this board was faulty, so one of these, I'm not sure which one, is faulty. Right, I'm just going to add a little bit of flux to, or I would if it would come off the syringe. A little bit of flux to those points where it's going to solder on. Alright, let's see if that will help us tidy up these points a little bit. Right, now like I said, I've got a problem. We've got a 50-50 chance because one of these chips that I took off works, I presume, and I presume one of them doesn't. So I have to get that to sit on there the same way the other one has. Like that. Let's see if we can hold him in place with the tweezers. Oh, that's not very straight. No, that's moved. In an ideal world I would know what I was doing, but I'm just doing my best here as a beginner. Oh, I think that's come off. I think the pad has tried to come off. Now that's a little bit crooked, that needs to go over. Come on, move over a bit further. Oop, no. Oh. Not having a lot of luck here. I think it's trying to lift the pad. Right, I think that might be on. I don't think I'm ever going to use this, by the way, I'm just playing. So, I don't think I'm ever going to risk actually using this. Right, before we replace the chip, this red naught, got to be careful with this because it's all plugged in and live. But if I get to there and there, hopefully you can see this is now reading 329. That should light an LED. I've changed the wires because they were really short and I didn't want to try and connect them to an LED strip, so I've put a red and black wire on there. So this is the side that was working before, that's the side that wasn't working before. Let's try turning it on and see what we get. And that's it. We've got two LED strips working. To show you that we really have got two LED strips working, there's the rest of them. So it would seem you can repair one of these if you're daft enough to try. I honestly wouldn't bother, they're fairly cheap to buy anyway.